And welcome back to my video series on vector algebra. So in this video we are going to be looking at scalar product of vectors. Now in the last video we talked about the sum of vectors, also called the resultant of two or more vectors, but here we're extending it down to product of vectors. Now when it comes to product of vectors, there are two basic ways we can multiply vectors. We have them to be called the scalar products. Scalar product is also called the dot product, and then we have the vector product. Vector product is also called the cross product. Now the reason we have the dot product to also be called the scalar product is whenever I multiply vectors, whenever I have the scalar product, your result is going to be a scalar. But when you have the vector product, your result is going to be another vector. So that's the reason we have them to be called the scalar product and the vector product respectively. Okay, so let's assume you have this vector. You have your usual vector A, and A is having 3 components, and then you have the vector B. B is also having 3 components. Then this is what you call their dot product, okay, also called the scalar product. Now as you can see, for their dot product, basically what we are doing is to multiply components. So we are taking the x component, multiplying it with the x component here. Okay, that's how we got this. So the same thing, you pick the y component, multiply it with the y component here. That's how we get this. And then you pick the z component, this is the z component, multiply it with the z component here, and that's how you get the third term we have here. So you're just multiplying them component wise, and you can see you're ignoring the I, j and k, so you're just picking the component of I, j and k, and then you multiply them correspondingly, then sum the result. Whatever you get there is what you call the scalar product. So you can see, since there is no I, j and k, your final result is going to be a scalar. Okay, now before we proceed to solve some problems on the scalar product, because that's the general concept behind the scalar product, before we solve questions on the scalar product, let me show you some examples on scalar products, some other concepts behind the scalar products. So one thing we have here is this: the scalar products of 2 vectors can give you 0. Now if it gives you 0, then it means those vectors are perpendicular. If you don't want to call them perpendicular vectors, you can also call them orthogonal vectors. Now for now, just take it that they are perpendicular or orthogonal. Later on you see that there is a slight difference between perpendicular vectors and orthogonal vectors, but in a general sense, they are the same thing here: perpendicular vectors or orthogonal vectors. Now another thing is that vector product or scalar product is actually commutative. So if I multiply A to B or I multiply B to A, it's actually the same thing. Later you're going to see that that's going to be different from the cross product, also called the vector product. Cross product is not commutative, but scalar product is actually commutative. That's why you have A times B being the same thing as B times A. Okay, take note of that dots. That's what we use for the scalar product. And again, when you have the scalar products of since we have these unit vectors I, j and k, the product between any two of them that are not the same thing is always going to be equal to 0. So scalar product I times j, j times k, k times I, and the rest of that, in as much as they're not the same thing, your scalar product is going to be 0, which means these vectors are perpendicular, and you can guess that by now. Okay, one of them is for the x-axis, one of them is for the y-axis, and these things are perpendicular to still the z-axis. They are all perpendicular. But what if they were to be parallel? What if these vectors were to be the same thing? Let's say we are looking at I times I, j times j, and k times k. Then in that case is going to give you 1. Now it's going to give you 1 when what you're multiplying are parallel and they are the same vectors. Okay, and they are unit vectors rather. If they are not unit vectors, it's not going to give you 1. So take note, this is not general. This only works for I, j and k, or only for unit vectors, this concept we have here. So take note of that. So now let's see some examples. So the first example we have, it said if A is that for I, j plus that, and B is that, and this is C. Okay, this is meant to be C. If C is this, so what they're asking us to do is to find a dot b, b dot c, and A plus 2C dot B. These are the things we want to find. So let's just see the solution. This one we are going to use my ugly writing with my pads to write it. So when we have the first case we want to find A dot B. So for us to find A dot B, all we need to do is to multiply the those vectors component wise. So when we say component wise, for A this is the x component, for B this is the x component. So you look at 4 times 7, that will give you 28, right? For B, the x component, the y component here, for A the y component here is 1, this is 1, and the y component we have here is minus 4. So 1 times minus 4 will give us minus 4. Okay, and in the last case we have this is 4, and what we have here is 2. So 4 times 2 will give you 8. So when you add these things up, 28 minus 4 will give us 24. 24 plus 4 will give you 32. So the result for the first case is 32. You can see how simple that is. Very simple. Within seconds we're already done. So the same thing, I want to find B dot C. So you can see the result we got is a scalar, it is not a vector, hence the name scalar product. So if I want to get B dot C, the same thing, I have to look at the components of B. This is what I have. B is 7i minus 4j, right? Then I have plus 2k. Then I'm multiplying it to C. Okay, let's swap this here. I'm multiplying it to C, and C we have here is 5i, don't mind this writing, minus 3j, then plus 5k, plus that's a plus 5k. So if we multiply these guys up, what we are going to get as a result should be 7 times 5, which is 35, if I know how to multiply. And this minus 4 times minus 3, minus will give us a plus, so that would be a 12. And this is 2 times 5, and that is going to be a 10. So if you add this up, this is going to give you 47, and that we have our result as 57. Okay, and with that we are done with that other one. So the next one I want to find, they said we have A plus 2C that will multiply it to B. Okay, so for just for the record, if you try to get B dot C, your result B dot A to be the same thing, C dot B will be the same thing. But here I want to get A plus 2C, then multiply the result to B. So you can guess by now the first thing we need to do is to find A plus 2C, right? So after almost I found A plus 2C, they will multiply it to B. So let's see what A plus 2C will give to us. So I have A plus 2C. So we have A, and our A we have there is 4i plus j plus 4k. These are A, and we are looking at A 2 times of C. So I have plus 2 times of C, and C we have there is 5i minus 3j plus 5k, right? That's what we have as C. So we are trying to multiply this and add them up. So let's try to jump a step, try to figure that out. 2 times 5 will give us a 10. 10 plus 4 will give us 14. So this is 14i. 2 times minus 3 will give us minus 6. Minus 6 plus a 1, that will give us minus 5. So the second term is minus 5j. Then 2 times 5 will give us a 10. 10 plus 4 will give us 14. So we have this to be 14k. So our result for A plus 2C is 14i minus 5j plus 14k. But that's not what they want us to get. They say we should use what we have here to multiply B as dot product. Okay, so that's what we are going to do in the next slide. So let's multiply. So we are going to say here that this means our A plus 2C, right? And we are multiplying that using dot product. We are multiplying that to B. So if I'm multiplying that to b, our result is going to be our a plus 2c. Now we got, I think, 14i, let's have a peek, minus 5j, and then we have, I think that should be 14k plus 14k. Then we are looking at the dot product of this and b, and what's b? B we have is 7i minus 4j plus 2k. So we have 7i minus 4j plus 2k, right? So if we add these guys up, or if we multiply them component wise, remember that's what dot product does. So 14 times 7, that will give us what? That should be 49, that should be 98, right? I think I have that right. So this should give us 98 as a result. I'm saying 98 onto the right, 96. So this minus 5 times minus 4, that will give us a 20. So this is 20. Then 14 times 2, that will give us 28. Okay, so let's add this up. So this and this will give us 48. 48 plus 98, that will give us 146, I think so. And that's 146. So you can try it out and see if you're going to get 146, but I think that should be the result, 146 for the third case. So that's it, guys, for the 3 questions they asked us to answer here. A dot b, b dot c, a plus 2c dot b. You can see the final result is also a scalar. All the results we got are scalars. So let's see the next example. Okay, so for the next example we have this. They said, are the vectors perpendicular? For us to know the vector are perpendicular, all we need to do is to find the dot product and see if we are going to get 0. If we get 0, then they are perpendicular. Okay, so if we find the dot product is a dot b, and that's going to give us component wise, we have 3 times minus 5, and 3 times minus 5 will give us minus 15. Then we have minus 5 times 5, that will give us minus 25, right? Yeah, minus 25. Then here we have 7 times 6. 7 times 6 will give us sorry guys, 7 times 6 will give us that should be 42, right? So that should be 42. So let's see what this will be. So this is going to give us minus 40, and this is plus 42. So our final result is going to be 2 as a result. So you can see what we have is 2, and since we know that 2 is not equal to 0, okay, 2 and 0 are obviously not the same thing. It means the vectors are not perpendicular, because we say for perpendicular vectors, the product is going to be, the dot product is going to be equal to 0. Okay, so that's, guys, for this particular question. So the next we have is this. They said, given these vectors, if they are perpendicular, find the value of x. So I'm going to let you guys to see how you can get the value of x. Try it before you move to the next video, but in the next video, that's what I'm going to start with, looking for the value of x, and then we'll look at some other cases. Okay, so I'll see you guys in this video. Bye bye.